This is part 6 of the series of videos on linear differential equations with constant coefficients. And today we are going to study how to find particular integral when the right hand side of the equation x is x raised to m, where m is a positive integer. We will focus our attention on finding the particular integral only. We have discussed at length how to find complementary function in my previous videos. Before we go into the procedure of finding the particular integral, let us recall the binomial expansion of 1 plus x to the power minus 1, which is 1 minus x plus x square minus x cube plus x raised to 4 minus so on and so forth, and binomial expansion of 1 minus x to the power minus 1, which is 1 plus x square plus x cube plus x raised to 4 plus so on and so forth. In order to remember these expansions, let us note that whenever there is a plus sign between 1 and x, the signs of the terms alternately change from plus, minus, plus, minus, plus, minus, etc. And when there is a minus sign between 1 and x, all terms are positive, and the terms in the expansion are same: 1 1, x x, x square, x cube, x raised to 4, etc. Hello friends, you are watching YouTube channel Number Collage. This channel features videos on mathematical concepts. Effort has been made to explore the concepts through basic mathematical ideas. Hope you will like my effort. Suppose we have fd equals the cube minus 3d plus 2, and the function on the right hand side of the differential equation is x, and we have to find particular integral of x. For that we have to operate 1 upon fd on x, that is, operate 1 upon the cube minus 3d plus 2 on x, but we cannot operate 1 upon d cube minus 3d plus 2 on x. For that we have to do some adjustment. So we write 1 upon, we take this constant term 2, a common factor here, and write the cube minus 3d upon 2 plus 1 into x. This we write as half into 1 upon, we write this 1 first, then minus, we write 3d minus d cube upon 2 into x, and finally we write this as half into 1 minus 3d minus d cube upon 2 to the power minus 1 operating on x. So the particular integral will be half into 1 minus, for this 3d minus d cube upon 2 we will put t to the power minus 1 operating on x, which is half into, now we can expand this 1 minus t to the power minus 1 according to this expansion. So this will be 1 plus t square plus t cube plus t raised to 4 plus so on and so forth operating on x, which is half into 1 plus t. We will ignore the terms t square onwards because t is 3d minus d cube upon 2, and derivative of x after d is going to be 0. So this will be 1 plus t operating on x, that will be half 1 plus, in place of t we resubstitute this 3d minus d cube upon 2 operating on x. This will be half into 1 into x plus 3d upon 2 is 3 upon 2 d into x minus d cube upon 2 into x, which is half into x plus 3 upon 2. D operating on x means derivative of x, which is 1, minus half d cube operating on x will be 0 because second derivative onwards derivative of x will be 0. So the particular integral will be half into x plus 3 upon 2 or x upon 2 plus 3 upon 4. So this will be required particular integral of x when operated upon by 1 upon d cube minus 3d plus 2. Suppose we have fd equals d cube plus 2d square plus d, and we have to find particular integral of x square plus x. So particular integral will be 1 upon fd operating on x square plus x, which is 1 upon d cube plus 2d square plus d operating on x square plus x. We can see we cannot operate 1 upon d cube plus 2d square plus d on x square plus x as it is. So we have to make some adjustments here so that we will be able to operate 1 upon fd on x square plus x. So for that, what we do is we write 1 upon, we will take d as a common factor and write d into d square plus 2d plus 1 operating on x square plus x, which is 1 upon d into, we write this as 1 plus 2d plus d square operating on x square plus x. We further write this as particular integral equals 1 upon d into 1 plus, we substitute t for this 2d plus d square. So 1 plus t, and we raise this to power minus 1 operating on x square plus x, which is 1 upon d into, we write this expansion from here 1 minus t plus t square. We ignore further terms because t square gives square of this d square, and we can find only two successive derivatives of x square and one single derivative of this x. Now we operate this on x square plus x, which will be 1 upon d into 1 minus, for this t we substitute 2d plus d square plus, for t square we substitute 2d plus d square whole square, and we operate this on x square plus x. Further, particular integral will be 1 upon d into 1 into x square plus x minus 2d into x square plus x minus d square into x square plus x plus the first term of expansion of 2d plus d square whole square will be 4d square into x square plus x. We will not take further terms in this expansion because derivatives of x square plus x, third derivative onwards, will be 0. So this will be 1 upon d into x square plus x minus 2, derivative of x square is 2x, plus derivative of x is 1, minus d square x square is double derivative of x square, which will be 2, d square x is double derivative of x, which will be 0, plus 4, d square x square, that is double derivative of x square, will be 2, and d square x, double derivative of x, will be 0. This is 1 upon d x square plus x minus 4x minus 2 plus 8. Further, particular integral will be 1 upon d into x square minus 3x plus 4. Now 1 upon d operating on x square minus 3x plus 4 is integral x square minus 3x plus 4 dx, which is x cube upon 3 minus 3 x square upon 2 plus 4x. So particular integral will be x cube upon 3 minus 3 upon 2 x square plus 4x. We have fd equals d square minus 4d plus 4, and we have to find particular integral of x cube. So particular integral will be 1 upon fd operating on x cube, which is 1 upon d square minus 4d plus 4 operating on x cube, which is 1 upon, we take this 4 a common factor and write d square minus 4d upon 4 plus 1 into x cube, which is 1 upon 4 into 1 upon 1 minus 4d minus d square upon 4 operating on x cube. So particular integral is 1 upon 4 into 1 minus 4d minus d square upon 4 to the power minus 1 operating on x cube, which is 1 upon 4 into 1 minus. We will substitute t for this 4d minus d square upon 4 to the power minus 1 operating on x cube, which is 1 upon 4 into, we will write expansion of 1 minus t to the power minus 1 according to this expansion, which is 1 plus t square plus t cube. We will write up to t cube only operating on x cube, because fourth power of this 4d minus d square upon 4 when operates on x cube will all be 0. This will be 1 upon 4 into 1 into x cube plus t into x cube plus t square x cube plus t cube x cube, which is 1 upon 4 into x cube. In place of t, we will put 4d upon 4 t minus 1 upon 4 d square into x cube, plus in place of t square we write t minus 1 upon 4 d square whole square x cube, plus in place of t cube we write t minus 1 upon 4 d square whole cube operating on x cube. So particular integral will further be 1 upon 4 into x cube plus dx cube minus 1 upon 4 d square x cube, plus the first term of d minus 1 upon 4 d square will be d square, so therefore this will be d square operating on x cube. Second term of the expansion of d minus 1 upon 4 d square whole square will be minus 2 times d into 1 upon 4 d square, that is 1 upon 4 d cube operating on x cube, plus first term of d minus 1 4 d square whole cube, which will be d cube operating on x cube. We will not consider further terms of this expansion operating on x cube, because all those terms will be 0, which is 1 upon 4 into x cube plus t x cube minus 1 upon 4 d square x cube plus d square x cube will be plus 3 upon 4 d square x cube. 2 ones are 2 twos are minus half d cube x cube plus d cube x cube will be plus half d cube x cube, which is 1 upon 4 into x cube plus dx cube is derivative of x cube 3x square plus 3 upon 4 d square x cube is double derivative of x cube, which will be 6x plus half d cube x cube is triple derivative of x cube, which will be 6. So finally this particular integral will be 1 upon 4 into x cube plus 3x square, 2 3s are 6, 2 2s are 4, plus 9 upon 2 x, 2 1s are 2 3s are plus 3. So this is the particular integral. If you like this video, please like, share and subscribe this channel. See you in the next video. Until then, keep watching Number Collage. Thank you.